again, what we're trying to do now is explore a deterministic MDP and have low mistake bound. The number of actions that we take that are suboptimal by more than epsilon is going to be, we need to bound it in terms of things. So let's try a little experiment. You're going to be the reinforcement learner.
Okay.
And I'm going to be the environment and tell you what's going on. So let's say we start off in this state here. Which action do you want to do, 1 or 2?
I want to, do I get to cheat and look to see what the...
You could, but I think that somehow isn't going to be quite as pedagogical.
Well, we'll learn a lesson for sure. I'll do 1. I don't even know which one is 1 and which one is 2 anyway. I'll do 1.
Yeah, I get to pick that. That's the good news from my perspective. I'm sorry, that cost you 8 points.
No.
Yes, but now we're here. So do you want to do 1 or 2?
Let's do 1 again.
That's not bad. You got +2 and you didn't go anywhere.
Just like grad school. Well, I've done 1. I know what that is. So let's try 2.
Okay. +10, so that's really good, but now you're someplace new.
Can I invent a time machine? Let's do 1.
Let's do 1. -6. Ouch. Now you're here.
All right, let's do 1. You know, when I was in that other state and I got a +2, I could have just stayed there forever. In fact, that probably was the right thing to do because I get infinite reward.
Well, it's discounted.
I set my discount to be 1.
No, you don't get to choose that.
That's not fair. Okay, so I'm sorry. I interrupted you.
All right, so you chose action 1. So I'll give you 1 point for choosing action 1.
And I end up in another state. All right, well, let's do action 1 again.
All right, so +1, and you get to be there again.
You know, if I just keep doing action 1 over and over again forever, I'll accumulate infinite reward.
No, sorry. You'll get 1 over 1 minus gamma.
Okay, I'll set gamma to be equal to 1.
No, that's not one of the choices I was giving you. You can choose actions.
Ah.
I should probably have told you gamma. I guess that would only be fair, right?
Well, I guess I'm not sure it's going to matter if gamma's less than, just as long as gamma's less than 1. All right, so I now know something.
You now know something. You know a lot of things.
So I do know a lot of things. I'm still in the same state, but I've got another action. I don't know anything about it. Let's try action 2.
+6, yay! And now you're at a state you've never been to before.
This reminds me of Zork. Okay, I'll take action 1.
It is like Zork.
It's exactly like Zork.
Hey, you're back to the state that you started in the very beginning.
I know -8 sucks. Actually, I now could basically do that cycle forever.
The series of actions that you just did that take you around this loop. Yes. Is that near optimal?
Well, if it involves -8, probably not. Let's do action 2.
Good idea. All right, so you're back to another state you've been to before.
And I got a -3 along the way, which is better than the -8. But not better than the -8 plus +2 some number of times +10, except gamma 0.9. Okay, so I know what action 1 gives me there, so let's do action 2.
Good job, you got a +4. And you're back here.
Oh, I'm in a nice little state, too, and I can do some little cycling.
Yep, and you tried action 1 from there.
Oh, but I never tried action 2 from here, did I? Let's do action 2.
All right, so action 2 turns out to be identical to action 1.
Oh, okay. That's complicated.
Cool, so now you're back at the initial state that you started in the beginning of time, and both actions that you have here, you've tried already.
And so I can say something about what could happen after that point, right? I know sort of if I take action 1, I get -8 +2 for some amount of time, +10, sort of the best I could do.
-10. +10.
Plus
you're
10.
Right.
Or I could do -3 and get immediately to this thing where I could go get +4s and +3s, which actually is better, I think. So I should pick one of those.
Well, okay, so here's an important point that we need to get to. So actually, you've explored the entire MDP except for one state action pair, this one here. And so if this edge is like a self loop with a reward of 1,000,000, then you have to find it. You have to get it, because otherwise you're not going to be nearly optimal.
Right, and I don't know that. So I have to get there.
Right. But on the other hand, let's say that we know that the highest reward is 10.
Okay.
So we have some bound, we'll call it Rmax,
All right.
on the largest reward in any state.
Mm.
Well, that could be really helpful, right? Because it could be that I can get a value by acting in the MDP that I have now, that even if this were 10, even if it were its highest possible value with, let's say, a self loop, we can still do better than that.
This feels very Minimax.
Well, it's R and max.
No, I mean, this feels like, it's a tree and I could do pruning. I mean, what you're basically saying is I should prune things if I already know that I can't do any better than some other choice that I have.
Yeah, that's right. So it has a boundish kind of feel to it. So what I'm suggesting is for any edge that we don't know, let's just be super optimistic and assume that it has value R max.
Yeah, that makes a lot of sense. And then I can already, if I pretended that's true for everything that I don't know, then that would tell me what to do, sort of in what the best worst case would be. And then I should try to get to the place that I think is good because I'm optimistic. And if it turns out I'm wrong, well, as soon as I get there, I will know that I was wrong. And I just keep doing that.
All right, let's write down the steps so that we don't have to hold them in our head so long.